So our first lesson is about solving simple equations, and that's probably not going to be new stuff for you. So I want you to pay attention not to like just what the answer is, but what's the process that we're using, right? Okay, so solving linear equations by adding or subtracting. We got to look at what some of these words mean, right? We use the word equation a lot, and sometimes we confuse it with an expression. An equation has to have an equal sign in it, and it's setting two things equal, setting two expressions equal to each other. A linear equation in one variable. A linear equation in one variable looks like this format right here, where A and B are numbers, right? A can't be 0 because then you wouldn't have a variable anymore. So this is a linear equation. One thing that so a linear equation is AX plus B equals 0. And you'll notice that for it to be a linear equation, you can't have any power on the x. You can't have like ax squared plus b. That wouldn't be linear anymore. The graph of that would be actually a parabola. But if you just have x with no power on it, that is just going to be the graph is just going to be a line. So that's why they call it a linear equation, right? You've seen like y equals mx plus b, and this is really similar. Ax plus b equals something, and then y equals mx plus b. You can kind of see how like y equals mx plus b is the equation of a line. So ax plus b equals 0 would be a linear equation. A solution is any value that makes the equation true. So any value that you could substitute in for the variable. Remember, a and b will just be numbers, and the x will still be the variable, the letter. So a solution would be any value that you could put in for the variable that would make the equation true. Inverse operations. Inverse operations undo each other, like addition undoes subtraction. They're the opposite of each other. That's inverse operations. Multiplication and division are inverse operations, right? If you multiply by 3 and then divide by 3, you'd get back your original number, right? Just like if you add 5 and then subtract 5, you're going to go back to your original number. When you do the same inverse operation to each side of an equation, the result is what we call an equivalent equation. And an equivalent equation is just two equivalent equations have the same exact solutions. Okay. Okay. So the process, or here's the concept that we're going to use to allow us to solve these equations. The addition property of equality. That's one property that we can use, and the subtraction property of equality. And technically, they're sort of the same thing because subtraction is just adding a negative, right? So you could just say addition property every time and probably just be fine. But the addition property says that if you have an equation, and then so like if we had an equation right here, like a equals b, and if we add the same number to both sides of the equation, we get an equivalent equation, right? Another way, like probably the easy way of saying it is you're allowed to add the same number to both sides of an equation, right? And that's something that you've probably done before. The subtraction property of equality is real similar. If you have an equation, then you can subtract the same number from both sides and you get an equivalent equation. And equivalent equations have the same what? Two equivalent equations will have the same solutions, right? So that means that if we're trying to solve this first equation, if we add the same number to both sides, it's an equivalent equation, so it has the same solutions. So for this slide, basically tells you you're allowed to add the same number to both sides of an equation or subtract the same number from both sides of an equation, and you still get an equivalent equation, which has the same exact solutions. And if I move too fast through the slides and you don't get to write everything down, that's another reason why I'll post the video afterwards, so you can go back, and if you're like didn't have enough time to jot something down, you can just leave a little space so you can go back and grab that. Or you can snap a quick picture or whatever you want to do. Okay, so let's do a couple of examples where we're going to use the either the addition property of equality or the subtraction property of equality. So the instructions say to solve each equation, justify each step, and check your answer. So solving each equation, here's my variable. So then what we have to do is we have to identify, like, so when I think about solving equation, I always think about, look at my variable and look at what operations are happening to my variable, right? And my goal is to basically get stuff away from my variable so that my variable is all by itself on one side of the equal sign. The way we get rid of anything that's around the variable is by doing an inverse operation. So right now, if we look at our variable, the only operation that's happening to it is subtraction, right? X minus 3 equals -5. Our goal is to get the variable by itself. We want to isolate the variable. And the way we're going to do that is by doing an inverse operation. The operation that's currently happening to X is subtraction. So in order to counteract that, we do the inverse operation, which is addition, right? The inverse of subtracting 3 is adding 3. And the reason we do that is because think about whatever, no matter what X is, X minus 3 plus 3 is X, right? If whatever X is, if you take 3 away and then add 3 back, you just have X back, no matter what X was. And then the addition property of equality says that if we're going to add a number to both sides, we have to add it to both sides in order to get equivalent equations as our result. So whenever you do an inverse operation, you do it once on each side of the equal sign. So you'll see me sometimes draw a little arrow straight down from my equal sign, and or sometimes just a line. And then that's the visual reminder for me to make sure that if I'm doing an inverse operation, I got to do it once over here and once over there. What you don't ever want to see, and I'll erase this in just a second, is here's a mistake that I'll commonly see. I'll be like minus 2.8, and then they'll do minus 2.8 on the same side. That's not okay. We can never do this. Subtracting it or adding it twice on the same side of the equal sign, that doesn't keep our equation balanced. We have to do it once on each side of the equal sign. The equal sign is like the middle of a seesaw, right? And if you add something to one side or the middle of a scale, so think about it like this. It's like a level, and that's the fulcrum is the equal sign. And if I add more weight on this side, that side's going to be heavy and go down. So I need to add the same amount of weight on this side so they'll be balanced out. So that's another way to think about it. Even though on this equation, adding 3 wouldn't really help us, would it? Okay, so then let's go back and figure out what's the result of adding 3 to both sides of this equation. So X minus 3 plus 3, that's just X. And then -5 plus 3. If you have problems with adding and subtracting with positive and negative numbers, I want you to try it and then just check with the calculator. Right? I got scientific calculators. I think they're right there in those white cases. If you need to borrow a calculator, I got you. Okay, but use a calculator to test your arithmetic. Like you're here to learn algebra, and so we're kind of assuming that you already know arithmetic. So if you have trouble, one thing that I really hate seeing is a student who gets the algebra, the logic part of it, but then adds incorrectly at the end, and then they don't get it right. So so use a calculator to do this, or to check your little arithmetic that you do. All right. So -5 plus 3. There's a lot of ways to think about how to do it, but basically I will look at it as -5 means I got 5 negatives. Plus 3 means I'm going to add 3 positives, and a positive and a negative cancel each other out. So you have more negatives. You got 5 negatives and 3 positives. 3 positives are going to cancel 3 of those negatives, and I have 2 negatives left. So -5 plus 3 is -2. Another way to think about that is like if you kind of visualize a number line, if you're starting at -5 and then you add 3, you're going 1, 2, 3 spots to the right, then you should be at -1, -2. Okay, so then for the second one here, we've got 0.9 equals y plus 2.8. And it really, we're used to always seeing like the variable on the left side of the equal sign, but it really doesn't matter. And honestly, if you didn't like the way this looked, an equal sign just says what's over here is the same as what's over there. It doesn't matter which side it's on. If you like seeing it like this, you can rewrite it like that. It's just the equal sign just means whatever's over here is the same value as whatever's over there. You can write it in either direction. Okay, so then our variable is y. The thing happening to y is a plus 2.8. So we need to do an inverse operation here, right? The inverse of addition is subtraction. So so now another question that comes up is, okay, do I subtract 2.8 or do I subtract 0.9? And the answer is always going to be, which one are you trying to get away from the variable? What am I trying to get? I want to get the y by itself. What's over here by the y? The 2.8. So that's what I need to get rid of because my goal is to get the variable by itself. So I'm going to subtract 2.8 from both sides. And I'm making sure to do it once on the left of the equal sign and once on the right of the equal sign. So the inverse operations, like they just undo each other. So when we just have y over here. And then we're doing 9 minus 2.8. Okay, so we got a positive, and then we're subtracting a bigger number. So our answer is going to end up being negative. We start with 0.9. We're taking away more than that. So our answer is going to end up negative. So basically what we do at this point is you subtract, and then you keep the sign of whichever one's bigger. So, so the way I'm going to do like the scratch work for this, I'm going to do 2.8 minus 0.9. And then I'm going to remember that the 2.8 was negative and bigger, so that means that my answer is going to be negative. Okay, so over here I have to borrow, right? So this is going to be 1, and then this will be 18. 18 minus 9 is 9. So we got negative 1.9 as our answer. And then the last part here says check your answer. How can we check our answer to make sure that it was right? First, I'm going to circle these so I know that they're my answers. So for the first one, we can check by, all you do is you take the original equation, and if you substitute your solution in, so we're going to, instead of x, we're going to write -2. And then you just check, is -2 minus 3 -5? Yeah. Like if I lost 2 things and then I lost 3 more things, altogether I lost 5 things. And then to check for part B, 0.9 equals y plus 2.8. Substitute -1.9 for y. -1.9 plus 2.8. That's basically, you're just going to do 2.8 minus 1.9, which we did up here, and you get, or no, we didn't. We did minus 0.9. But if you do 2.8 minus 1.9, I'll borrow from there. 18 minus 9 is 9. 1 minus 1 is 0, so you get the 0.9. So our solution for A was x equals -2. Our solution for B was y equals -1.9. Okay, so let's kind of work through these a little bit. These ones you don't have to put in your notes. but let's go through them. All right. What would we do on number one? What operation would we do to both sides of the equal sign? We need to subtract 3 from both sides, right? We have our variable has a +3. The opposite of that is -3. So we're going to subtract 3 from both sides, and we get the inverse operations just cancel each other out or undo each other, and we get n equals -10. What operation should we do on number 2? We need to do addition, right? So even though we got a funky looking thing over here, we still know it's subtraction, right? So the opposite of subtraction is addition. And even though it's a fraction, it's still a number. Fractions are numbers too. So we just have to make sure we're adding the same number to both sides, even if it's a wacky number that is not our best friend. And then we look at, all right, the inverse operations undo each other. So we're just going to have g left over here. And then if the operation over here isn't easy to do in your head, you can just write, all right, right now I'm just going to say, all right, this is -2/3 plus 1/3. Because I'm not used to adding fractions vertically for some reason. Like my brain doesn't like to see vertical added fractions. I don't know why. For some reason, it's easier for my brain to remember that when we're adding fractions, if we write them like this, remember adding and subtracting fractions, you have to have the common denominator. And so in this case, we already have the common denominator, so we just do -2 plus 1. -2 plus 1 is -1, so it's going to be -1/3. So even though like this was fractions and the last problem was decimals, we're using the same process, right? We're identifying what operation is happening to the variable, and we're doing the inverse to both sides of the equal sign. Okay, for number 3, P has a +3.9 next to it. So we're going to do a -3.9 to both sides of the equal sign. So a -6.5 -3.9, thus they're both negatives, so we just add them together and keep the negative. So 5 plus 9 is 4, carry the 1, and then that'll be 10, so -10.4. And you could leave it like this, -10.4 equals P. If you feel like switching it, you can do P equals -10.4. They mean the same thing. Okay, so we just went over when it's addition or subtraction, right? Where the only thing happening to the variable was addition or subtraction. So we used the addition or subtraction property of equality to solve those. Now we're going to look at multiplication and division. So it's real similar. If multiplication and division are inverse operations for each other, so they undo each other. So the multiplication property basically says you can multiply both sides of the equation by the same number. So if you have A equals B, and then you multiply both sides by the same number, as long as that number is not 0. Because if you multiply it by 0, you lose your variables, and then you just have 0 equals 0. You didn't really accomplish anything. And then similarly, if you have an equation, you can also divide both sides of the equation by the same number, but it can't be 0 because you can't divide by 0. So these are real similar to the addition and subtraction. Multiplication and division is just you can multiply both sides by the same number, or you can divide both sides by the same number, just as long as that number is not 0. Can't hear you, sorry. So next we're going to use these properties to solve some simple equations like we did with addition and subtraction. Oh, hey, there's a bigger version. All right, so let's look at some examples. So for this first one, negative n over 5 equals negative 3. So sometimes we'll look at that and be like, okay, this is a fraction, what's going on? But fraction really just means top divided by bottom, right? So this is really just saying n divided by 5, and it's negative, right? So what's happening to the n right now is it's being divided by 5. And technically, it's also being multiplied by -1. So what we can do, the opposite or the inverse operation of division is multiplication, right? So we're going to take this equation, negative n over 5 equals -3. And the n is being divided by 5. And the opposite of dividing by 5 is multiplying by 5. So we're going to multiply both sides by 5. But we can do like a little trick and do a little 2-for-1 action because we want to get the n by itself, right? And if we multiply by 5 right now, we're going to be left with negative n over here. So all we really need to do is just say, instead of multiplying by +5, let's multiply by -5. Because then the negative times negative here will become positive, and then you'll have positive n left, right? So the multiplying by 5 is like the inverse of the dividing by 5. And multiplying by the negative cancels out this negative because negative times negative is positive. So if we multiply both sides by -5, we're going to end up with n on this side. And then over here, -3 times -5 is positive 15. And then on here, you can kind of do like a little kind of a mental check, right? Negative, you put a 15 in for n, 15 divided by 5 is 3. So then you'd have -3 equals -3. So that's our correct solution. All right, B might be a little aesthetically confusing, like the way it appears might be like, huh? But your job when you're solving an equation is always to first identify the variable you want to solve for. So the variable we want to solve for in this situation is x, right? Pi is actually just a number, right? It's 3.14, blah, blah, 159, blah, blah, blah. So basically, what we have going on right here is x being multiplied by a number, right? So x is being multiplied by pi. The inverse of multiplication is division. So we're just going to divide both sides by pi. All right, so the inverse operation undoes the multiplication by pi. Another way to think about it is pi over pi is 1, right? And 1 times x is just x. And on the right side of the equation, pi divided by pi is just 1 also. So these, in a sense, a lot of people will say they cancel out, but really they just divide out because they're what pi divided by pi is 1. And 1 times -2 is -2. And then for C, our variable is Z. What's happening to the variable? It's getting multiplied by 1.3. So we need to divide both sides by 1.3. 1.3 divided by 1.3 is 1. 1 times Z is Z. And then you can just do 5.2 divided by 1.3. And honestly, if you used a calculator to do all of your multiplying and dividing, it wouldn't bother me at all. I like it when you at least try first and then check to see if you did it right with the calculator. So 5.2 divided by 1.3 is 4. So Z equals 4. Also, so one thing that you'll notice is that in algebra, we don't use an X for multiplication anymore because we use that to be a variable now. And depending on your handwriting, you got to be careful when you write a Z, because sometimes people's Z's look like 2s. And like halfway through the problem, your Z might turn into a 2, and then you're like not even doing the same problem. So one thing I do is, like, when I'm doing a Z, if my Z doesn't look enough like a Z, I'll do like one of these little things just to remind myself it's a Z. But whatever works for you, do you. Okay, what are we going to do on number 4? Our variable y is being divided by 3. So the inverse of dividing by 3 would be multiplying by 3. So we're going to multiply both sides of this equation by 3. On the left side, times 3 divided by 3 cancel each other out. 3 divided by 3 is 1. 1 times y is y. And then negative 6 times 3 is negative 18. When it says justify each step, they want you to say, I used the multiplication. So actually, this step right here is when we use the multiplication property of equality. Technically, we should have been saying that every time we did that, but I forgot. Number 5, sometimes when they throw pi at us, it kind of like, it's trying to look like a variable, but it's really not. So we just remember what's happening here for real. Our variable is x. It's getting multiplied by the number pi. So we just need to divide both sides by the number pi. And then the pi's divide each other out on both sides, right? Pi over pi is 1. Pi over pi is 1. So we get 9 equals x. And then on this number 6 here, our w is our variable. It's being multiplied by 0.05. So we're going to divide both sides by 0.05. And both of these are using the division property of equality. So then we're going to get w equals, get a calculator, 1.4. And remember, fraction always means top divided by bottom. 1.4 divided by 0.05 equals 28. By the way, did you ever wonder why the division symbol looks like this? It's a fraction. This is the numerator, this is the denominator. The division sign kind of just tells you that that fractions mean division, and it's top divided by bottom. Okay, last example, word problems. So in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Right? And so write and solve an equation to find his average speed to the nearest hundredth of a meter per second. Okay, speed. And they said in meters per second, right? So do you know that per, you know what operation per implies? Like meter per second. If you're going to put an operation in place of per, it would be division. Meters per second is like meters per second. It's meters divided by seconds. And we can get that from, if we forget that, we can always remember that by using the distance equals rate times time formula. And average speed, that's the rate, right? So if we look at d equals r times t, and if we want to find out the rate or the speed, then we think about the rate as our variable and we get it by itself, right? If r is our variable and we want to get it by itself, we need to get rid of this t next to it, right? Well, what's the t doing? It's multiplied, right? D equals r times t. So we can use the division property to divide both sides of this equation by t. T divided by t is 1, right? So those cancel out. So we get r equals distance divided by time. Rate equals distance divided by time. And the distance is measured in meters, and the time is measured in seconds. So if we just use this formula, we're going to get our speed in meters per second, because distance is meters, seconds is time. So we're going to use rate equals distance divided by time. His distance was 200 meters. Time was 19.32 seconds. Then we're going to have our calculator help us again. 200 divided by 19.32. So, and they say to round to the nearest hundredth. That's 2 decimal places. So 10.35, there's a 1 after it, so we stay at 5. So 10.35. Meters per second. 10 meters. Okay, so this is the end of that question. We answered it. His average speed was 10.35 meters per second. Think about that. Like, it's kind of hard. In America, we don't really use meters as much. But a meter is about 3 feet, or like a yard in football. So think about that. He goes 10 yards every second. It would only take him 10 seconds to run all the way down the football field, you know, like pretty intense. And then let's see. Oh, yeah, we'll not do that one. You want to do this one? This is the last one. Suppose that he ran the 400 meters at the same average speed, okay? So that means that his speed is 10.35 meters per second. That's the one we just got. How long would it take him to run 400 meters? Okay, so again, we're going to use the distance equals rate times time. This time we want to know about how long would it take. So the variable that we're trying to solve for is time. How long would it take? So if we want to solve for time, time is currently being multiplied by the rate. So we can divide both sides by rate. and then we get a formula for time. R divided by R is 1 times T is T. So we get time equals distance divided by rate. The distance is 400 meters. We want to find out how long it's going to take him to run 400 meters at a rate of 10.35 meters per second. And one interesting thing is if you look at the units here, meters divided by meters is going to go away. Meters divided by meters, M divided by M is 1 no matter what. And then you have seconds in the denominator down here. And when you divide by something in the denominator, that turns into multiplication. You remember dividing by a fraction is the same as multiplying by the reciprocal. So our units are going to be in seconds because the meters cancel out. And then we just got to do 400 divided by 10.35. And we get 38.64. And then the next number is a 7. We want to go to the nearest hundredth, so we want 2 decimal places. So 38.64. And then we look at the next digit to see if we stay at 4 or round up to 5. And in this case, the next digit's a 7. So we're going to round that 4 up to a 5. So 38.65.